In this lesson, we're going to be talking about functions. So we're going to talk about something that's like a function machine where we put in a number here and a number will come out and you have to figure out the rule. So let's take a look at an example. Here were some inputs with their corresponding outputs. Let's see if we can figure out the rule. So when we inputted a 0 into the function machine, a 2 came out. When I put in a 1, a 3 came out. When I put in a 7, a 9 came out. When I put in a 4, a 6 came out. So what we want to figure out is what's happening inside of this function machine to give us the output that we need. Well, what we're looking for here is a pattern. If you notice, if you add 2 to every input, it gives you the output. 1 plus 2 gives me 3. 7 plus 2 gives me 9. 4 plus 2 gives me 6. So the rule is going to be we're taking our input, which we can call x values, and we're adding 2, and that's going to give me my output. Okay, here's an example that looks to be a little bit harder. So for this one, we have some input. So we input a 0 into our machine, and we get a -1. We input a 1, we get a 1. We input a 7, we get a 13. And we input a 4, and we get a 7. So this one's a little bit more difficult to find the pattern, but I'm going to take this row here. To get to 13, one thing that we can do is we can multiply this by 2, which would get us to 14, but then to get back down to 13, we'd have to subtract 1. So that seems to be a rule that works for that line. Let's see if that works for the previous lines. So let's take 1, we're going to multiply that by 2. 1 times 2 is 2. And we're going to subtract 1. 2 minus 1 is 1, so it works for that line. Let's see if it works for the first line. 0 times 2 is 0. We're going to subtract 1. That gives me -1. That works. Now let's check the last line. 4 times 2 is 8. And then we're going to subtract 1. 8 minus 1 is 7. So the rule here seems like we're taking the input or the x values. Another thing we can call this is the domain. We're multiplying it by 2, so I'm going to write it as 2x, and then we're going to subtract 1. That's going to give me my output, which is a y value. Another thing we can call this is range. Okay, so we have the same machine. We've discovered the rule. The rule is 2x minus 1, but what if I told you we're going to go ahead and take a 4, and we're going to put it in the machine, and we get a 9? Well, we saw in the previous line that when we inputted a 4, we got a 7, right? So if we input a 4 again, what we would expect is that we would get a 7. However, I'm saying that in this case, we end up getting a 9. So this machine is no longer functioning the way that we would expect, right? Because we can't figure out if we put in a 4, if we're going to get a 7 or if we're going to get a 9. It's unpredictable. Okay, so now let's get into the notes here. So a relation is the mapping between a set of input values called the domain and a set of output values called the range. So the values that we input are called the domain, and for those we use x values, and our output values we call the range, and for those we use the y values. So relation is just describing how a value in the domain maps to a value in the range. There's many ways you can display a relation. You can display them as ordered pairs. You can display them as a table. You can display them as a mapping diagram. You can display them as a graph. So we're going to look at a few different examples in a minute. So now let's define what a function actually is. So a function is a type of relation that assigns each element of the domain exactly one element of the range. So in other words, we can put that in simple terms. For every x value, there is exactly only one y value. So as we saw in that example a few slides ago, when we put a 4 in the machine, we should have gotten a 7, but when I put a 4 in the machine again, I got a 9. That is no longer a function because that x value has two y values. An x value can only have exactly one y value. Right, so here's our example, right? Our x value of 4 now has two separate y values. A 4 goes to a 7, but it also goes to a 9. So this is no longer a functional machine. So this would be considered not a function because we have an x value that has two y values. Okay, so to determine if something is a function, regardless of what type of representation it is, so in this case we have two examples of a table and a mapping diagram. So a table lists the x values and lists the y values, or the domain and the range. We need to check if every x value has exactly one y value. So in looking at this table, my first x value is -1 and it maps to a y value of 1. If I look down at the rest of my values, there are no other -1s, which means we know that that has exactly 1. So then we go to the next number. 2 goes to 0. I look at my domain and see if there are any other 2's in my table, and there aren't. So that means 2 goes to exactly one value. The next line, we're going to look at 5. That goes to -5. In looking at my x values, there are no other 5's, which means that maps to only one value. The next line is 6. That goes to -5. And again, we're looking at our x values. 6 is the only x value in our domain, and it has exactly one y value. And then lastly, we have a 7, which goes to -8. And there are no other 7's in my domain, which means that for every x value in our domain, it has exactly one y value. So you might be looking at this and saying, well, wait, I see -5 twice. Remember, the definition of a function is that every x value has exactly one y value. It's okay if that y value is seen multiple times as long as it's a different x value. Okay, so we're going to say, yes, this is a function. Because every x value has only one y value. Okay, so let's look at the second example. This is called a mapping diagram. So it's essentially the same thing as a table, except you're not going to see duplicate numbers in the domain and the range. So if we look at each of these, I'm going to go through each number or each member of the domain. So the first member of the domain is 1. According to this arrow, 1 maps to 2. So since that has exactly one y value for that particular x value, that's okay. If we go look at the second example, though, we have the number 4. 4 is not only going to 5, but it's also going to -5. So since that's an x value and it has two separate y values, think of this like a machine, right? If I put in a 4, for it to be a functional machine, I want to know exactly what is going to come out of the machine. Well, since 4 maps to 5 and -5, I don't know if I'm going to get a 5 one time or if I'm going to get a -5. So in this case, we're going to say this is not a function. And I'm going to give my reason, because 4 in the domain maps to both 5 and -5. Okay, let's look at a few other representations. So the next representation is just a list of ordered pairs. Remember, in an ordered pair, the x value comes first and then the y. So I'm just going to go ahead and label these to make sure we know which is the x value and which is the y value. So I'm going to go through and look at each x value first. So looking at -2, according to my first ordered pair, that maps to 2. Now I'm going to look at my other x values and see if there are any other -2's. Since there aren't, we know that that pair is okay. So far, this is functional. Next x value, I see 0, and that maps to 2. Looking at my other ordered pairs, I don't see a 0, so this ordered pair is functional so far. Looking at my next pair, I have a 3, -4, so my x value is 3. According to this ordered pair, 3 maps to -4. But if we look at our next ordered pair, it says that 3 goes to 5. So if we think of this as like a mapping diagram, we have 3 in our domain, and in our range, 3 is going to go to -4, and it's going to go to 5. So since there are 2 arrows coming off of 3, again, think of it as putting it into a machine. If I put in a 3, I want to know exactly what I'm going to get out. Well, when you put in 3, sometimes you might get a -4, sometimes you might get a 5. So in this case, this is not a function. So no, not a function, because 3 maps to -4 and 5. All right, the next one is a verbal relation. So it says the relation between students in your school and each student's birthday. So our input are going to be students at our school. So think if you pick any random student at our school and you ask them what their birthday is, they're only going to give you one response. No single student can have 2 separate birthdays. You might have 2 different students who have the same birthday. That's okay, that's still functional, but every single individual student has one single birthday. So for this, we're going to say yes, because each student has only one birthday. And in this case, each student is our X value, and the birthday would be the Y value. So for every X value, there's only exactly one Y value. All right, the third example is an equation. So this is y equals 2/3 x minus 1. So you might think, well, how am I supposed to determine if this is a relation? Remember, we need to see if we put in an x value, we get exactly one y value. Basically saying, if I plug in an x value, so say for instance, I plug in the number, we'll say 3, am I only going to get one single y value? So let's plug in that number. So I have 2/3 times 3 minus 1. So to remind you, the way that you multiply a fraction times a whole number is you can turn that whole number into a fraction, and then you just multiply the top number. So 2 times 3 is 6, and multiply the bottom numbers, the denominators. 3 times 1 is 3. Then we have 6 divided by 3 is 2. So that's 2 minus 1, which is 1. Okay, so when I plugged in the x value of 3, I got 1. So that gives me an ordered pair of 3, 1. If I plugged in 3 again to this equation, I'm only ever going to get 1. In fact, if I plug in any value, I'm going to get a unique y value. So because I'm getting a unique y value for every x value, this is a function. So I'm going to say yes, because every x value has only one y value. Okay, so the next type of relation is a graph. So there's actually a pretty easy way to determine whether a relation is a function, and that's using what's called the vertical line test. So remember that vertical lines are lines that go up and down. So to apply the vertical line test, we take our graph and we draw a vertical line through the graph. Okay, if it intersects only once, then we consider it a function, because remember, x values are on the horizontal axis. That means a single x value has only one y value. If it intersects more than once, so here's an example of where it's intersecting at 2 points, that means for this particular x value, whatever it is here, there are 2 y values, which is not okay in a function. That's why we consider this not a function. So when we're doing the vertical line test, we want our vertical line to only touch our function once. All right, let's take a look at 3 more examples. So looking at number 1, we have it in a table. So again, we're going to check every x value and make sure it only goes to one y value. So -1 goes to 4. I don't see any other -1, so we're good so far. 0 goes to 0. Okay, but in looking at my table, I see that there's another 0 in my domain, and that's going to a different number, 4. So since 0 goes to both 0 and 4 in our range, we're going to say, no, this is not a function. So not a function, because 0 maps to 0 and 4. Okay, looking at number 2, this is a mapping diagram. So we're going to check that every x value goes to exactly one y value. So right off the bat, looking at my first number in my domain, which is 2, according to this mapping diagram, 2 goes to 7, but 2 also goes to 20. So right away, I know that this is not a function because 2 maps to 7 and 20. And remember, in a function, every x value has one unique y value. All right, looking at number 3, this is a graph, so we can actually apply the vertical line test here. If I draw vertical lines, and I can draw many of them, as I see for every vertical line, I'm only intersecting my graph once, which means that for any x value, it's only going to have one y value. So for this particular problem, we're going to say, yes, this is a function. Okay, it doesn't say to explain why, but I just said it verbally. Every x value has exactly one y value. All right, number 4, these are ordered pairs. So in ordered pairs, we're going to look at all the x values first, which I'm going to highlight in blue just so I can differentiate. So I see -7 goes to 5. There are no other -7s in my domain. So next one is -5. I don't see any other -5s in my domain, so that's okay. I see a 2. There are no other 2s in my domain, so that's okay. And then I see a 3. There are no other 3s in my domain, and that goes to a single value. So this would be considered a function because every x value has exactly one y value. So I'm going to say, yes, this is a function. Okay, this is from the homework, so I'm going to go over number 3. So we're going to determine if this is a function. So this is a mapping diagram, so I need to check that every x value has only one y value. All right, so starting with -4, -4 goes to 11. -4 is not going to any other number, so that's okay so far. Now I'm going to look at -1. -1 goes to 14, does not go to any other number, so that's okay. Then we have 0 goes to 11. It doesn't go to any other number, so we're okay there. And then lastly, I see that 3 goes to 2. So in this problem, since every x value has exactly one y value, we're going to say, yes, this is a function. So I'm going to say because every x value in the domain maps to only one y value. In the range.